Welcome to our foundation channel. From class 10th mathematics, the chapter number 9 is matrices. So in this chapter, let us see first definition. What is the matrix? How we can arrange and types of matrices. How many types are there in that? Main important addition, subtraction and multiplication of the matrices. So addition, subtractions are easy concept and matrix multiplication by using scalar and matrix multiplications or matrix with another matrix. So order of the matrix, different types, how the questions will come. So all topics one by one I'll explain. So those are watching the first time, you can subscribe to our channel and see the link in description below about the material of this particular chapter and other series and other content also, right? Now let us begin the topic. First let us see what is matrix. So a matrix is a rectangular arrangement of numbers arranged in rows and columns. If you arrange some numbers, now for example 1, 2, 3, 4. These four numbers I am arranging in rectangular arrangement like 1, 2, 3, 4. So if we maintain some box or bracket, now arrangement of numbers arranged in rows and columns is nothing but a matrix. Now here is a two rows and two columns, right? See another example. I arranged 1, 0, 3, minus 1, 6, 4. There are total 6 numbers arranged in rows and columns. 2 rows and there are 3 columns. So matrix is a rectangular arrangement. Even square is also a rectangle, right? So like rows and columns, arrangement of numbers arranged in rows and columns. It's called a matrix. And there is only one row, like for example 1, 0, minus 1. Even if you observe, there is one row but three columns. Three columns are there, even single element, three columns and one row. So this is also arrangement of matrix, right? These are the example. And plural of matrix is matrices. So matrices word you can see, the plural, singular is matrix, plural is matrices. So each number or entity in the matrix is called element. Every number which are entering in this matrix, those you can call element. So these elements we can use with numbers or small letters, even alphabets you can use it small. In a matrix, the horizontal line is called rows. Horizontal line, right? So these two are rows. So let's say this R1 and R2, row 1 and row 2. And vertical lines are called columns. So this is a vertical line. This is column 1, this is column 2 and column 3. So vertical lines are columns, horizontal lines are rows. So here is two rows in this, right? R1 and R2. And there are two columns, column 1, column 2. This example is only one row, but there are three columns even though this. So column 1, column 2, column 3. Right? So rows is horizontal lines and vertical lines are columns. Just remember that. Now let us see the order of the matrix. What is order of a matrix? So this is nothing but the order of the matrix is number of rows in it and number of columns. Always use the rows first. Now in this example, there are two rows and three columns. So we'll use the cross symbol in between, but we can read it as 2 by 3. So remember, if a matrix has two rows and there are three columns, right? So you can read it as 2 cross 3. We read it as 2 by 3. So if any matrix has m rows and n columns, so m rows and n columns, we can read it right as m cross n, but we'll read as m by n. Okay, that means m rows and n columns. Other two examples you observe. Here is two rows, two columns in this. In this only one row, three columns. But don't confuse this 1 into 3. This is 1 cross 3, but we read as 1 by 3. One row, three columns. The meaning of this is two rows, two columns. Right? So all the numbers or the which is given within the box, no, those are the elements. So elements of the matrix. And every element we have the particular position. Let us take 1, 0, minus 3, 2, 1, 4. If you observe this, this is in first row, first column, this element. Let's take this. 4 is in, this is rows, no, second row, third column. So second row, third column. This is first row, first column. First row, second column. First row, third column. So every element we have the particular position. So rows and columns. Which row, which column it is given, that we can take. So this matrix is 2 rows and 3 columns. Total 2 rows, 3 columns, right? These are the basic definition of the matrix and how we can identify and how we can write. Let us see the types of matrices and how to identify, how to use those types in the problems. Types of matrices. So to solve the problems in matrix, we should know at least the basic types. What are the types are there in matrices? How to apply those even in the problems, let us see. First, let me show all the 7 types of matrices. First one is row matrix. First type is row matrix. You can see the word meaning in this. So row matrix means a matrix which has only one row is called row matrix. Only one row. If there is only one row in the matrix, that's called row matrix. So let's say example, there should be only one row, right? So A, B. There's only one row but 2 columns. Even you can take -1, 0, 3. So if you see the order, this is only one row but 2 columns. This is one row and 3 columns. So a matrix which has only one row is called a row matrix, right? First column, second column, but only single row. Your first column, second column, third column, but only one row. So a matrix has only one row is called row matrix. Next one, column matrix. Column matrix. You can see the meaning in this. Column matrix. Row matrix only one row, right? So column matrix must have only one column. If any matrix, a matrix which has only one column is called column matrix. See the example. There should be only one column. -1, 2. So there's only one column, but there are 2 rows. This is 2 rows at only one column. And same like -1, 0, -1. Any numbers. Here we have 1, 2, 3. 3 rows, but column is only one. 3 rows and one column. Always to write the order of the matrix, you must write rows first, followed by columns. Any matrix order when you're writing, you write the rows followed by column. So there's only one column, here is only one row. So a matrix which has only one column is called a column matrix. So it's always order will get column place is 1. Right. Next one. Square matrix. We have 7 types. So in this square matrix, you can see the meaning from this word square, right? So actually the meaning of the square is 4 sides are equal. So length and breadth must be same. That means a matrix which has equal number of rows and columns. Rows and columns are equal. There is a square matrix. Now my 2 minus 2 0 1. Observe this. 2 rows, 2 columns. So here is rows. Number of rows should be equals to number of columns. Number of rows must be equal to number of columns is a square matrix. Sorry, it's equal. Change this. Rows and columns are equal. Rows is equals to columns or number of columns. Number of rows exactly equal to number of columns. There is a square matrix. Even this is 2 rows, 2 columns. Let us take one more. 3 rows, 3 columns. 3 minus 1 0, 1 4 6, 3 minus 1 5. There are 3 rows and 3 columns. Right? A matrix which has an equal number of rows and columns is called a square matrix. Now in case if it is not equal, that is fourth one, rectangular matrix. Generally if you see the rectangle property, the length and breadth is not same. So same method, same meaning will apply in this. Rectangular matrix. Rectangular matrix is rows is not equals to. So number of rows not equals to number of columns. Right? Number of rows not equals to number of columns. So let's take 3 minus 1, 0, 1, 4, 6. Observe here, 3 rows, 2 rows and 3 columns. This is row 1, row 2, column 1, column 2, column 3. So 2 rows and 3 columns. So number of rows are not equals number of columns. A matrix in which the number of rows are not equals to number of columns is called a rectangular matrix. And fifth one is the zero or null matrix. Zero word is there, no, null. If each element of the matrix is zero, it's called the zero matrix or null matrix. Every element in the matrix must be 0. 0, 0, 0, 0. This is 2 rows, 2 columns, all are zeros. Even 0, 0, 0. 3 rows, 1 row, 3 columns. 1 row, 3 columns. So this is the zero matrix. If each element of a matrix is 0, that's all. So it's called a zero matrix. And next one, diagonal matrix. Diagonal matrix. So actually no, diagonal is only come for the square. Means first row, first column to last row, last column should have the straight line, which must be square only. A square matrix which has all its elements is 0 except those are leading in the principal diagonal is called diagonal matrix. Let me show example. So only in square matrix like 2, 0, 0, 3 or one more 5, 0, 0, 0 minus 1, 0 and let me take 0 here, 0, 0, 3. If you observe here, a square matrix, these both are square matrix. So this is a 2 rows, 2 columns, 3 rows, 3 columns. Principal diagonal, first row, first column to the last row, last column. First row, first column to the last row, last column. A matrix which all its elements 0, each except those on leading diagonal is called. Except those on the diagonal, remaining elements must be 0. So that type of matrix, those matrix only called diagonal matrix. Right. Now based on this diagonal matrix, we have the one more type, unit matrix. Unit matrix is diagonal matrix value should be always 1, remaining are zeros. Here we have 2 0 0, right? It must be 1 0 0 1. All the diagonal elements must be only ones. If you write 3 rows, 3 columns, 1 0 0, 0 1 0 and 0 0 1. This is a diagonal matrix in which each element of its leading diagonal is always 1. It's a diagonal matrix, but the principal elements in this diagonal should be equal to 1. It's called unit matrix or identity matrix. You can call it as a identity. Identity matrix will use the letter capital I. So this is equal to I. This is 2 rows, 2 columns, identity matrix, 3 rows, 3 columns. So these are the main 7 type of matrices in this. You can notice. And additional to one thing I'll show you, transpose of matrix. For example, matrix A is having elements 2, 3, 1, 0, 1, 4. This is one a rectangular matrix, right? If you want to find out A transpose of matrix, we can use this A to the power T. So you can use this denote like this, A to the power T. This you can use as transpose matrix. This interchanging rows to the columns. Now this first row 1, right? You can write as first column. This you can write column 1. So 2, 3, 1. Next to second row, you can write as second column. That is 0, 1, 4. So interchanging rows and columns. Transpose of a matrix. You can use transpose of a matrix is just interchanging rows to the columns. After interchanging its rows and columns. So rows to columns are interchanging nothing but Even columns also interchange to rows, right? This is the column 1. It becomes as row 1, 2 0 2 0, right? And second column in this 3 1, it becomes second row. This is third row. If you interchange rows to columns, it's nothing but columns to rows also. That means transpose of a matrix is the matrix obtained on interchanging its rows and columns, right? So these are the basic types, and we have the one more equality of matrix. When we can say two matrices are equal, let's say A is 3 1 0 4, same place, same elements. So let's say B is also 3 1 0 4, then we can say A is equals to B. A matrix exactly equals to B matrix. So corresponding elements must be same place, right? Then only A is equals to B. Let us say C is a matrix. It's X, Y, P, Q. If A is equals to C, then what is the value of X, Y, P, Q? A is equals to C, right? So first one exactly equal to the first one. 3 must be equal to X. So X is equal to 3. Then Y is equals to 1. Same way P is equals to 0 and Q is equals to 4. Whenever two matrices are equal, those corresponding elements should be equal, right? This is the concept used in the problems also. Next, when you're doing addition, subtraction, multiplication of the matrices, this concept will apply. Whenever two matrices are equal, those corresponding elements must be same, right? These are the types. Let us continue with addition and subtraction, the multiplication of the matrices. Addition and subtraction of the matrices. So to add or subtract the matrices, we should know the compatibility for addition and subtraction. The compatibility is both matrix must have the same order. So number of rows and columns should be same in the both matrices. Let me take a small example first. So here is matrix A is 2 1 5 6. So this is 2 rows and 2 columns. Matrix B is 3 2 1 4. 2 rows and 2 columns. Order of the matrix is same. Then only addition and subtraction is possible. Let me take this example for addition. A plus B. So the meaning of matrix A adding with matrix B is adding the corresponding elements like 2 1 5 6. B matrix is 3 2 1 4, right? So to do addition of this, we are supposed to add only the corresponding elements. Two elements should add with this 3. 2 plus 3. First matrix, first column. First matrix, first row, first column to next matrix, first row, first column. Again 1 plus 2. These two. First row, second column. Same first row, second column. Corresponding elements. We should add. 5 plus 1. Same place. 6 plus 4. Simple. Like normal additions, we can add, we'll get the answer. So that is 5, 3, 6 and 10. 5, 3, 6, 10. So this is the addition. Same logic will apply for subtraction of the matrices. So compatibility is they should have same order. So matrix A and B have the same order. Now if you want to subtract A minus B, matrix A is subtracted with matrix B. So A minus B is, first we should take matrix A minus matrix B. So here is A is 5 4 2 1 in this. 3 0 4 2. So subtract this, corresponding elements you have to subtract. Same place. 5 here minus 3 there. 4 minus 0. Next 2 minus 4. 1 minus 2. That's it. You have to simplify to get the A minus B matrix. 5 minus 3 2. 4 minus 0 4. 2 minus 4 is minus 2. 1 minus 2 is minus 1. So if you observe once, A plus B and B plus A will get same answer. But A minus B is not equals to B minus A. That means it's not a commutative property. Subtraction is not commutative. Right? That you can remember. Addition and subtraction should have the same order. Then only we can add or subtract. Let us see the problems in this one more. Okay. So this is the question. In this question, A is 8 6 minus 2 4. Matrix B is minus 3 5 1 2. Then solve for 2 by 2 matrix X such that matrix X we have to find out. Before solving this, first A plus X is also matrix is equals to B. So we need to find out matrix X value. A plus X, now if you take A right side minus A. So already B is there, B minus A. If you find out B minus A, then that thing but matrix X. So B minus A, matrix B you write, minus you write the matrix A. So here is B is minus 3, 5, 1, 0 and A first place. So 8, 6, minus 2 and 4. Right. So we supposed to simplify this. That means corresponding elements you can subtract. Remember here this is the minus 3 minus 8 here. Next 5 minus 6. 5 minus 6. Second row this first column 1 minus this is the for question minus it is. Again element is minus 2. So just to maintain the bracket and write. So I should be careful here. 1 is as it is minus of this minus 2 again. 0 minus 4 next place. Just to simplify you'll get this answer. That is the matrix X. X matrix is the result is minus 3 minus 8. So minus 11, 5 minus 6 minus 1, 1 minus into minus no plus 1 plus 2, 3, 0 minus 4 is minus 4. Right? This is the matrix X. Same way, see this one more sum. Second one, first only you can simplify. The question is X minus B matrix is A. We need to find out matrix X. So minus B if you take right side, A plus B. If you find out A plus B, there is nothing but matrix X. So matrix A plus matrix B you can add. So in this question, A is 8, 6, matrix A, right? 8, 6, minus 2, 4. And B is minus 3, 5, 1, 0. Yes, you can do addition, you'll get the answer. So you can, if you're perfect ones, you can do directly. 8 plus minus 3. That means 8 plus of minus 3. Plus into minus. So minus 3 directly. 6 plus 5. And minus 2 plus 1. 4 plus 0. Corresponding elements. You can simplify, you'll get the answer. That is 8 minus 3 is 5. 11 minus 1 and 4. This is a matrix X. So addition and subtraction should have the compatibilities. Order should be same. Then only we can do adding or subtracting. Right? Let's go for the multiplication process. Multiplying with scalar element and multiplication with of between two matrices and based on the problems. Multiplication of matrix by a scalar. So this is the multiplication of matrix by scalar means each and every element in the matrix you should multiply that particular number. So let us see one example. If 2a, so here is A is a matrix and 2 is an element, so 2 is a scalar. For example, let A is a matrix 2 1. Okay, only this is a single row and 2 columns. The meaning of this is take this number 2, each and every element in this matrix is supposed to multiply. Right? 2, 2, 1. So 2 into 2 and 2 into 1 is supposed to multiply. That is 4 and 2. Every element in the matrix you should multiply with scalar. So to multiply a matrix by scalar means each of its element by the scalar is supposed to multiply. Right? See the examples and go for the problems. 2 within the bracket if is the matrix 6 minus 4 0 3. The meaning of this is the matrix and 2 is a scalar. We should multiply every element with this 2. Here is 2 rows 2 columns. So result also will get 2 rows and 2 columns. 2 6 12, again 2 into minus 4 minus 8, 2 times 0 is 0 and 2 3 is a 6. So this is the resultant matrix multiplication scalar. Let us see the problems how will come this concept. Yes, so here is the question. Given A, B, C are three matrices, find A plus 2B minus 3C. 2B, 2 is a scalar, we are multiplying with matrix B. 3C. Matrices will use the capital letters A, B, C, right? And 2 and 3 are the numbers or scalar here. Find A plus 2B. So A plus 2B minus 3C. Meaning is first A matrix is as it is plus 2 into matrix B minus 3 into matrix C. We have to simplify after substituting the values. So matrix A is 1, 2, minus 2, 3 to B. B is matrix minus 2, minus 1, 1, 2 minus 3 C. C matrix is 0, 3, 2, minus 1. Right. We are supposed to simplify first. Before that, this is the matrix before there is no any scalar. Say same as it is. 1, 2, minus 2, 3 plus. Here is 2 into this matrix. We are supposed to multiply. Only with 2. 2 into minus 2. Minus 4. 2 into minus 2 is minus. Okay. 2 into minus 1 is minus 2. 2 ones are 2 and 2 twos are 4. Next, you can remember here minus is as it is. Only with this 3 I am going to multiply this. Not minus 3. Minus is as it is. Only with 3 you are going to multiply each and every element. So 3 zeros are 0, 3 threes are 9, 3 twos are 6, 3 into minus 1 is minus 3. So whenever the negative sign before the element, negative sign as it is, only with the 3 you can multiply. Right. Next step, we can add this 2 first. Addition and subtraction of the matrices we did, right? Same type. 1 plus minus 4. So minus 3. And 2 plus minus 2. So 0. And minus 2 plus 2. 0 again. 3 plus 4 is 7. Minus 0, 9, 6 minus 3 as it is. Next simplification. Subtraction of the matrices. Minus 3 minus 0. Minus 3 it is 0 minus 9. Minus 9. Again same corresponding elements. 0 minus 6. Minus 6. 7 minus of minus 3. So observe here. 7 minus of minus 3. No? 7 minus 2 minus plus 3. That is 10. So 10 will get here. This is a rough I did. 7 minus of minus 3 is 10. So this is the value of A plus 2B minus 3C. Right. Let us see if one more sum based on this scalar, multiplication with scalar. Now, this is the question. Matrix A, B is given. Previous one is 2 rows, 2 columns, 2 by 2. This is the 2 rows, 1 column, 2 by 1. Find matrix X such that A plus 2B is equal to B. First, let us take this. A plus 2X is equals to B. X matrix we are supposed to find out. So 2X is as it is. A take right side, B minus A. Okay, 2X is equal to B minus A. First you'll find out the B minus A value. So matrix B minus matrix A. So B is minus 1, 7 minus A is here 5 minus 3. First simplify this. If we do minus 1 minus 5. So minus 6, 7 minus of minus 3. So this is plus 10. So actually this is 2 into matrix X. So observe here. Now this is 2x. No, 2 is multiplying with x. Take either side. It's 1 by 2. Now x is you can write 1 by 2 into matrix minus 6 and 10. 2 into x, right? 2 you take other side. It's actually nothing but 2 by 1. So it becomes 1 by 2. Reciprocal. To transpose to right side. Now 1 by 2 is the scalar. Multiply every element. That is minus 1 by 2 into minus 6. 1 by 2 into minus 6. Again 1 by 2 into 10. You just simplify. That is the matrix X. Okay, 1 by 2 into minus 6. 2 ones are 2, 3. So minus 3. 2 ones are 2, 5. So 5. So X is equal to minus 3 and 5. This is the find matrix, no, X value. So this is the concept. So simple thing. Only to multiply a matrix by scalar means to multiply each of its elements by the scalar. Each and every element you have to multiply that. Based on that we can take the X value and simplify. Right. This is the multiplication scalar. Let us see multiplication of matrices. One matrix how to multiply the next matrix. Multiplication of matrices. So this is one of the important in this matrix. So it's not like a direct addition and subtraction type. We have to follow some procedure to multiply these matrices. First, let us see the compatibility for multiplication of matrices. To multiply any two matrices, let us say A is 3450 and matrix B 1234. Right? Let us take this. To multiply these two matrices, we should not multiply corresponding elements. So this is wrong. First, if you see the feasibility, number of columns in A is equal to number of rows in B. Now this is 2 rows, 2 columns. It's also 2 rows, 2 columns. So first matrix columns should be equals to second matrix rows. Then only matrix multiplication is possible. You remember that. First matrix columns should be equal to, that should be equal to second matrix rows. So first matrix columns equal to second matrix rows. Then matrix multiplication is possible. Then result will come remaining numbers. So result will come again 2 by 2. First matrix rows and second matrix columns. Whichever the result will come in that way. Now for example, matrix A is having 2 rows 3 columns. Matrix B is again 2 rows 3 columns. So matrix multiplication is not possible in this because first matrix columns is 3, second matrix rows 2. So it's not equal. So it's not possible. In this type of examples, matrix multiplication is not possible. Right? First, let us see how to multiply the matrix. Then you can see this rule is exist or not. You can get understand. Now let us take AB. Matrix A should multiply with matrix B. Now A is 3450. Matrix B is 1234. To multiply these two matrices, the first step is first matrix rows, because result will come 2 by 2, right? This is 2 rows and 2 columns. Then result will come 2 by 2 order. Now this is the total 1, 2, 3, 4 places. Now this is the first row, first column, first row, second column, and second row, first column, second row, second column. So if you observe this, let me take one example here, rows and columns. Now this is the row 1, column 1, and second row, this is the same, first row and second column. Next, second row, column 1, second row, column 2. Right? This is the pattern. First row, first column, first row, second column. This is the second row, first column, and second row, second column. This is the position. Now here this value is first row, first column. You have to simplify. That is, this is the first row with first column. Corresponding elements you multiply and add. That means 3 into 4 plus 4 into 3. This is 3 into 1 plus 4 into 3. First row, first column. Here is 2 elements, there are 2 elements. So first row, first column, 3 into 1 plus next element with next element. So we have to simplify next step, we get the answer. So that is 3 ones are 3 plus 4 threes are 12. So 3 plus 12. Then result will come this 15. So 15 we got, right? Now the next with first row, second column. This is row 1, column 2, right? So same with first row with the second column. We should make it here. 3, 4, 2, 4. So 3 into 2 plus 4 into 4. Corresponding elements. We need to multiply and add the set. So 3, 2 and 4 with 4. So 3 2s are 6 plus 4 4s are 16. 6 plus 16. So you'll get 22. So first row, second column is over. Next position is row 2, column 1. So this is first matrix, second row, and second matrix, column 1. This is so second row, first column, because this place is second row, column 1. Now 5 into 1 plus 0 into 3. 5 ones are 5 plus 0 3s are 0. So that is 5. Right? Now we'll show it the color. Now again, this is the row 2, column 2. So second row with second column marking. So second row and second column. So one row from first matrix and column from the second matrix. 5 0 2 4. So 5 to 2 plus 0 and 4. First element and second to second element. 5 2 is a 10 plus 0 4 is a 0. So 10 plus 0 is 10. Right? This is the matrix multiplication. So remember this pattern. Rows, columns, first row, first column here, first row, second column. Next, second row with first column, second row, second column. We'll take first row, all the columns we can do correspondingly. And we'll take the second row again with all the columns. Let me show examples, you'll get more clear idea. Let us see this question. A matrix, B matrix is given. Find AB and BA. So first AB. Matrix A multiply with matrix B. Let us see AB and BA difference. So matrix A is minus 2, 3, 4, 1. B is 1, 2, 3, 5. Okay. This is a matrix A and matrix B. As per the rule, you're supposed to multiply first row with first column. I'm keeping markings. First row with first column. Right? Minus 2 into 1 plus 3 into next number. 3. Right. Next, again with first row, next column. So minus 2 into 2 plus 3 into 5. Right, it's over. Next again we start with second row, again with first column. Second row, first column. 4 into 1 plus 1 into 3. Again with second row, second column. Second row with second column. 4 into 2 plus 1 into 5. You just simplify, you'll get the result. So minus 2 plus 9. Minus 2 plus 9 is 7. Right. Minus 2 into 2, minus 4 plus 15. So 11. 4 plus 3, again 7. 4 to the 8 plus 5. So 13. This is a matrix AB. Next, we're supposed to find out the BA. Second matrix. BA is nothing but first we should take the matrix B followed by A matrix. You can notice one thing, AB and BA is not commutative property. So actually multiplication is exist, but in matrix is not commutative property. Let us see with example. First AB we did know, we got 7, 11, 7, 13. Let's go for the BA. So B is 1, 2, 3, 5. Next A matrix is minus 2, 3, 4, 1. Yes, as per the rule, first row with first column. First row, first column. 1 into minus 2. Minus 2 that I am taking. Plus 2 into 4, 8. Once a perfect, you can do directly. Again with first row, next second column. 1 into 3, 3 plus 2 into next 1, 2. Next with second row, again this first column. 3 into minus 2, minus 6 plus 5, 4 is a 20. Next one. Second row, second column, observe. 3, 5, 3, 1. So 3 into 3 is 9 plus 5 1 is a 5. Simplify, you'll get the answer. So minus 2 plus 8. So 6, 5, this is 14 and 14. So AB and BA are different. Therefore, AB is not equals to BA. In matrix multiplications, AB and BA is not same. Right? The result is not equal here. So remember, matrix multiplication is not commutative. This is the thing. Let us see one more problem. We'll have more idea. You can see I is unit matrix. So actually we saw the types of matrices. Unit matrix is 1 0 0 1. Because of all the given matrix is 2 rows 2 columns. You take identity matrix 2 by 2. 2 rows 2 columns only. We have to evaluate a square minus 3a plus 2i. A square means A matrix should be multiplied again A. A square is equals to A into A. Remember, 3A. 3 should multiply with every element in A, you should multiply 3. Now hence, let us take, remember this, A square is A into A. So we have to supposed to find out A square minus 3A plus 2I. I is identity matrix. That is equals to A square, right? So matrix A multiply with again matrix A minus 3 into matrix A plus 2 into identity matrix. Here is 2 minus 1 minus 1 3. Same matrix you take 2 minus 1 minus 1 3. Ax again 2 minus 1 minus 1 3. I is 1 0 0 1. Identity matrix. Already you are perfect with matrix multiplication. Just apply now. So first row, first column. Not of keeping every time line. Just remember first row, first column. 2 to the 4 plus minus 1 into minus 1 is plus 1. So plus 1. Again in first row, next column. 2 into minus 1 minus 2 and minus 3. 3 into minus 1 into 3, right? Again in second row, first column. So minus 2 minus 3, second row is second column. Minus 1 into minus 1 is plus 1. 3 3 is a 9. Minus with 3 you can multiply inside. 3 into 2 6, only 3, not minus 3. 3 into minus 1 is minus 3, again minus 3 9. Plus with 2 you can multiply. 2 1s are 2, 2 0 0, 0 again 2. Simplify and you can calculate this to get the final answer. So this is 5 minus 5, again minus 5 10. This value minus 6 minus 3 minus 3 9 plus 2 0 0 2. If you got the answer directly, you can calculate corresponding elements. Subtract first two, add with third one. You get it directly. 5 minus 6 plus 2, 1 it is. Next minus 1 minus of minus 3, minus 5 plus 3, minus 2 plus 0. So minus 2. Subtract first and add third one, that will get. Or else minus 5 plus 3, 0, no, minus 2. 10 minus 9, 1 plus 2. So 3. So this is a square minus 3a plus 2i. Any question is asking this expanding type or elaborating, you can do separately and subtract directly, or else do together in single step. Right. We'll see one more type of sums in this, will get clear idea. This is the question. This matrix is multiply this, result is this one. Find x and y. Observe here, first matrix is 2 rows, 2 columns. Second matrix is 2 rows, 1 column. 2 rows, 1 column. So first matrix column, second matrix rows are same. Matrix multiplication is possible. Now the result is minus 2 8 it is. So as per the method, first row with first column, right? So my 3 into x, 3x plus minus 8 into y. So minus 8y. First row, first column is over. Because result will come 2 rows, 1 column. 2 by 1 will come. 2 rows, only single column. No more column again. Next again with second row, again with first column. 9 into x. 9x plus 4 into y is 4y. So whenever two matrices are equal, corresponding elements are same. Use that rule. So 3x minus 8y is equals to minus 2. You get equation 1. Again 9x plus 4y is equals to 8. Equation 2. Right. Already we solved elimination method or substitution method to find out the values. Just to find out, you'll get the answer x is equals to 2 by 3 and y is equals to 1 by 2. I'm not showing the method here. You can take the coefficient same and use the elimination method to find out. Right. These are the basic concepts in matrix multiplications. So most of the questions will expect similar type. The important thing is how to multiply the matrices. You should know clearly in this. So this is the pattern. Pattern you remember and practice. It will be easy for you to do any calculations. Most of the problems in this class you get 2 by 2, 2 rows, 2 columns only matrix multiplications. So other 3 rows, 3 columns you don't have syllabus. Maximum up to 2 by 2 order only you can find out. Right. Who is watching the first time now, you can subscribe to our channel. See the links in description below for our material and other information.